Okay, continuing on with chapter 4, section 5. Here's just a general a definition for what we have been doing this entire time. The general power rule, a formal definition of what that is, and it's just we've been doing this entire time. We got the integral, all right, and so we have an inside function, the derivative of the outside function outside. This is exactly what we're just doing on our assignment. We just have all we have here is a formal definition of what that actually is. All right. Same thing down here with the u substitution. We just have a formal definition of what that is. Here's the new power. Here we're dividing by the new power, adding 1 to the power, dividing by the new power. So all that is the formal definition. So if you ever see that on a formula sheet or anything like that, just know that's how you take the integral. That's what we've been doing. Okay. So another thing that we need to talk about is a change of variable for a definite integral. Sometimes it's a lot easier for us just to evaluate, to make a u substitution and then evaluate the integral with respect to u. And all we have to do is we have to change our upper and our lower bounds is what we have to, that's all we have to change. So our upper and lower bounds, and then once we change those, it might make taking our integral much easier. All right. So what we do is when we substitute in for u, all right, we just got to figure out then what u equals when x equals our upper bound and our lower bound. Okay. So you'll see that here in a little bit. So what I'm going to do, we're going to evaluate just using u this integral right here. Okay, so let's go ahead, let's make u equal our inside function, right? So u is going to equal, x squared plus 1. And then so du is going to equal 2x dx. And dx is going to equal du all over 2x. Okay. So what I'm left over here now, I have the integral from 0 to 1 x times u cubed dx. And remember, we substituted in for dx then. So let's substitute in for dx. All right, so dx equals du all over 2x. We have u cubed x from 0 to 1. All right, and this is the x canceled out. All right, so now what we have left over is the integral from 0 to 1 of u cubed du. Now, previously we've just been taking the integral, and then we've been plugging u back in, and then we've been evaluating from 0 to 1. But what we can do is we can change our limits of integration here, all right, to what u equals when x equals 0 and when x equals 1 up here. All right, so we can substitute in, then all we have to worry about is plugging in values into u and cubing it, and then we have our integral, our definite integral. Okay, so let's change our upper and our lower limit. So our lower limit, right, is going to be when x equals 0, what does u equal? Well, that's up here. Well, when x equals 0, u is going to equal 1. So our new limit, our new lower limit is going to be 1. Our new upper limit, we're going to plug 1 into here, into x. 1 squared is 1, plus 1 is 2, so our new upper limit is 2. And now we have u squared du. The purpose of that now, or u cubed, sorry, u cubed du. Now the purpose is we can take the integral and evaluate it at 1 and 2 without having to plug in this u back in. All right, so let's take the integral. All right, and we get u to the 4th all over 4 evaluated at 1 and 2. So then we still go top minus the bottom. So 2 to the 4th power divided by 4. 2 to the 3rd power is 8. So 2 to the 4th power is 16 divided by 4 is 4. And then we plug in 1. 1 to the 4th power is 1. All over 4 is 1/4. Right? So we're going to get a final answer then of 3 3/4. So a lot of times it's easier for us then just to evaluate it using u instead of having to plug u back in. So we would have had to plug this back in and then evaluate from 0 to 1. All right. Sometimes it's a lot easier for us. So I just want to show you this method as well. Here I'm going to have another one here. Okay. So let's evaluate the integral from 1 to 5 of x all over the square root of 2x minus 1. Now this is going to be one of those difficult ones, and you'll see it, not really difficult, but it's going to take a little bit. Okay, so we're going to make our inside function, since it's inside the square root, we're going to make u equal 2x minus 1, and therefore du equals 2. Maybe already 2 dx. Sorry, maybe already you've seen where our hiccup's going to come is we're not going to be able to have this x cancel out. We did a problem like this in the last video. So you should have kind of an idea where I'm going with this. So dx is going to equal du all over 2. So let's go ahead and substitute everything. We have x all over the square root of u dx, and let's plug in for dx. All right, so let me go ahead and erase this. Dx, we'll substitute in du over 2. Now, normally we've had pretty nice integrals where those just canceled out. There's an x here and it just canceled out. Well, in this case, it doesn't. All right, remember what we had to do is we had to go back up into here, and well, let's figure out what x equals in terms of u. So we'll add 1 over, so I have 2x equals u plus 1, and then divide by 2. So I have u all over 2 plus 1 all over 2. All right, or u plus 1 all over 2, whatever works best for you. So let's go ahead and let's plug that back into our integral. So we have our integral from 1 to 5 of u plus 1 all over 2 divided by the square root of u du all over 2. Okay. Since we're in terms of u, we might as well change our upper and our lower limit now. So when we get done, we just evaluate it in terms of u. So let's change. All right, so our new lower limit, when we plug 1 back into up here for x, all right, u is going to equal what? So let's plug 1. We go 2 times 1 is 2 minus 1 is 1. So our new upper bound is going to be 1. All right. And our new lower bound, we plug 5 in. I'll have 10 minus 1 is 9, so 9. Okay. We can do a little bit more cleaning up here. If you realize this is a fraction divided by a fraction, so if you think about it, let me write off in green. I'm going to erase it here in a little bit, but over to the side, it's u plus 1 divided by 2 divided by the square root of u. Well, that's just dividing fractions. We multiply, we save it, change it, flip it, right? So this really is u plus 1 all over 2 times the square root of u, right? So what I'm saying from this is I have a 1/2 on the bottom, and it's also times du over 2. So there's also a 2 on the bottom here. Let's go ahead and when we multiply these two, we have a 1/4. So let's pull a 1/4 out. All right, so we get rid of our 2's in the denominator. And then we just have u plus 1 all over the square root of u du. Something like this came up on our assignment, our last assignment. And we said it was probably easiest for us. So let's break this into 2 separate fractions. And as long as we have the same base, we can subtract our exponents. So I have u to the first minus u to the 1/2. So I'm going to have u to the 1/2. So now I have the integral from 1 to 9. Let's simplify this now. Of u to the 1/2 power plus 1 all over u to the 1/2. So I have u to the negative 1/2 power. Okay. So let's go ahead and, don't let me forget my 1/4 out front here. All right, so let's go ahead and take the integral. So when we take the integral, we're going to have, first of all, we're going to have 1/4 outside. We take the integral, we're going to have u to the 3/2 power and divide by the new power 3/2, so it's going to be the 2/3 power. Plus, add a power, we're going to have u to the 1/2 divide by the new power 1/2, so we're going to have 2. All right, let's go ahead and simplify before we evaluate at 1 and 9. Let's bring our 1/4 through. When we bring our 1/4 through on this one, this is going to cancel out to be a 2. This will be a 1. So I'm going to have, let's see, I'm going to have 1/6 u to the 3/2 power. Plus, then when I cancel, this 2 is going to cancel out. It's going to be a 2 as well. So I'm going to have u to the 1/2 all over 2. And we need to evaluate this at our new limits, which are 9 and 1. I said I was going to erase this stuff earlier. Let me clear some room for us. Okay, so now we just need to evaluate it 9 and 1. Well, when I plug 9 and I cube 9, I take the square root of 9, okay, I'm going to get 27. So when I plug 9 in there, cube 9 and then take the square root, we're going to get 27. So I'm going to have 27 over 6 plus, well, the square root of 9 when I plug it into here. The square root of 9 is 3, so I'm going to have 3/2. Minus, then, when I plug 1 in, I'm going to get 1/6. So let's move my minus down here. Minus 1/6 plus 1/2. Okay, let's go ahead and bring my cross the line, change the sign, bring all these up here. Okay, so if I combine my 1/2 and my 3/2, I'm going to get what, 1? When I combine my 27 over 6 and my negative 1/6, I'm going to get 27 over, or 26 over 6. So now we add these, so this would be 6 over 6. So I'm going to get, what, 32/6? 32 over 6, which is 5 1/3. Right? So that last part was just dealing with fractions. It got a little messy over here because I kind of ran out of room. But hopefully that the U substitution, a lot of times it helps us instead of having to go back and plug in 2x minus 1 where we saw a U way over here and then trying to evaluate, it would have been a little messy. So I think using the new upper and lower bounds made this problem quite a bit easier. And the more you do it, the more you get used to it, and you'll find that it's much easier. So we'll see you in class, and have a good night.